Alright, so today I decided to make a video about automating boilerplate. It's really late and I can't go to bed, so I figured I might as well make a video. Um, so, where to get started? So I made a helper script um, just to show you what it does here. Um, so I have boilerplate that I need to add to my code base. Like if I want to make a new UI, I want to add boilerplate. So in the game I'm making, um, there's UIs. Every time you make a UI, you also need states with it, and the states will, determine what's going to happen with the UI. And as you change states, different things can happen within that UI. For example, if you're in the world UI in the main state, you might just be walking around the world, but in the pause state, you could be navigating through the pause menu while the world is running. Or in the talk state, you might be there might be a text box on the bottom of the screen while you're in the main world. That'd be the talk state for the world UI. Yeah. So I can make, so here's my UIs, right? This is in this folder. If I want to make the boilerplate for a new UI, I can go to scripts, helper, and then do new UI. Oh, helper, new UI. Make it even bigger. I know it's pretty big, but new UI, and then call it like do things. Boom, whatever. So it's going to add the boilerplate. So here's the UI. This is the boilerplate code. But it needs states too. Well, actually split the window. It also needs states. So you'll see here if I do look for do things. You'll see it right here. There's a directory do things in the states directory. It added, this in the init file, the main state, and then added the boilerplate for the main state. And also, if you look in the main init, it adds this init function right here. And it will add it after all the other init functions. So it'll search, where the init functions are in the main init, and then at the bottom of all the callings of the init functions, it'll add a new one at the bottom. Also, so yeah, that's what that does. I could also do, so let's remove that. I could do remove UI, do things, and oh, whoops. There you go. Now that call for do things doesn't exist. The directory in states doesn't exist. Look up do things. I don't even have the do things UI in the UI directory. But I also have an option in new directory, new UI, I mean, for a sprite sheet. So here, I'll show you before, right? This is what the call function looked like. You notice how some of these init functions have this string in the beginning? The string is the sprite sheet, right? So let's say I wanted to make a UI that needed a sprite sheet. Also, I don't know if I opened it before. I didn't open it before, but the UI was a little different for do things. We'll just say that. So add new UI, sprite sheet, sprite, some sprites.png, and then call it do things again. And you'll notice, boom, it actually has the some sprites string here. And in here, you notice this function, this is different. This boilerplate's different. It has sprite sheets. Before it was this. So it's a little different. And we see we have in states, we have the do things state, and then here added the main again. Now if I want to add a state for this UI, I can still do that. So I could go to my helper, new state for do things, and the state will be something. So now I made a new state called something, added the boilerplate. Also, we'll notice in the init, added this require. Yeah, you notice this ends in a comma and this ends with a semicolon. I'll have to change that later, but not important. So yeah, and then if I wanted to remove the UI, I could helper remove UI, remove state. If I want to remove the state, I could remove state from do things something. So now, whoops, did I do that right? Yeah, I did. Now, if I refresh this, you notice that something doesn't exist anymore in the require, and then the something state down here, that file disappeared. So I will search for that script. Call it helper. Yep, so I have a new UI function. I have a new state function. I have a remove state function, remove UI function, and then I have something that searches through the arguments for the script. And in the beginning of this searches through the arguments in the function. Well, at least that's just for the new UI function. So I'm going to break this down a little bit more. You notice how I didn't indent the function like that? That's because this cat right here, when I have a here doc right here, that's what these two less than symbols are, is a here doc. This EOF needs to start at the beginning of the line, and I can't. Where did that go? Did I do something weird? I did do something weird. I can't do this for. See, that's an error. Remove indentation before the two less than symbols. It needs to start at the beginning of the line, and if I push this forward, then that's gonna, show in the file indents, and I don't want that. So yeah, that's why it's not indented. It actually, I think, looks nicer not indented. If it was, it'd be weird because there'd be some indenting and some not indenting. So anyways, this right here, this is going to complain about double quoted arrays expansion to avoid resplitting. I actually want splitting here, so that error is not an error. I'm taking advantage of splitting. So for args, and the at symbol is all the arguments for this function. And I really should call this arg and not args because I'm going through each argument. That makes more sense. And then if the argument is equal to this, if I find this argument, which I'm going to call this is a flag, then I'm going to take this. I'm going to assign a sprite sheets variable to the second argument, which would be the argument for the flag. And then I'm going to do shift 2, and that just essentially removes the arguments. So that the first argument. So if I called helper, if I called helper like this, and then I did sprite, I'll just write it down here. If I called helper like this, then I did sprite and then I provided an argument, right? And then I did shift 2. So this is the first argument. This is the second. And once I do shift 2, let me write that out again. Once I do shift 2, anything after these two arguments will be considered the first argument now. So now if I did whatever, now, oh, what the heck happened? Now whatever is going to be considered the first argument. If I did shift 1, if I did shift 1, then this would have been considered the first argument. I accidentally called that. Well, it's all right. Remove UI ASDA. Right. Okay. Yeah. So that means this flag requires an argument when I shift 2. But you can see I added here that S. I didn't add anything to it. But if I wanted a flag that didn't require an argument, so in this example, I do something here, but it doesn't need an argument. I could just shift once. Because in this case, right, if that flag S, like this, and then I do something, right? Well, once I call this flag S, I do what I need to do. Now I can consider anything after that the first argument. Yeah. So that does that. Then I check to see if the UI direction, the Lua file for the UI exists, or if a directory for states for the UI exists. And if either of those exist, then I exit. This means I print std error, and then I exit with the return value as 1. I was trying to remember the name of that. I think it's just called return value. Whatever. Yep, then I check to see if... And keep in mind, when I'm telling you the breakdown of the script, this isn't so you can copy my script. This is just so you can get an idea of how to write your script. Then I check to see if the variable sprite sheet exists. And I'm setting it right here if this sprite sheet flag is set. And if the variable sprite sheet exists, then I'm going to write to this file. So how I'm doing this is I'm doing cat. And cat, normally if I do cat license, right, it just prints a file to the terminal. But in this case, we want to print a string. So what I do is a here doc, which I said before. So it starts with these 2 lines. Then you have, a symbol following those two. It starts with those 2 less than symbols, and you have something block of text following those 2 symbols. And then you can write anything after that block of text, and you can even do new lines, whatever you want. But then once a new line starts with another new line starts with EOF that says, oh hey, or whatever the symbol is, the block of text you made, then it's going to say, okay, well then that's the end of the string. Or yeah, we'll into the fake file, right? And all this text right here is going to be our fake file. And then this greater than symbol is saying I want to write whatever comes from this cat command into this file. So that's what I'm doing there. And you notice how it's a single less than and not a 2 less thans. That means I'm writing to the file, and whatever there was, if there was anything there before, it's not going to exist. It's just writing to the file. Anything that was there before, it isn't going to exist. Making a directory, boom. Another one of these cats, writing some more boilerplate here. Do it a few times. This, I have 2 greater than symbols, which means I'm writing to the end of the file and appending at the end. Yep, but it's pretty much the same approach. And then I have a grep here, and this grep, this -n says to use the line numbers. E says to use extended ASCII. I don't think I need to use that extended ASCII. but I did anyways. I'm going to copy this into the plus register real quick. Do the quote plus then Y to copy into the plus register if you didn't know. And the plus register, if you didn't know, is also the register for your system clipboard. And then I'm going to paste that into here to show you what outputs. But I need to do a file, so I'm going to do for init.lua. Oh, something's not right. I need to end the quote. There we go. And it shows all of the UI calls, UI init calls, right? And the lines that they're on. So that's right here. Right. But we only want to see the line numbers, so we're going to do this cut. We're going to pipe in this cut. So what we're going to do is do cut dash field 2 delimiter colon. Boom. So field 2 means, so if we look at above out here, so this is the first field before the colon delimiter, and this is the second field, it's everything after that colon delimiter. And if you had, I don't know, something like echo hello there world, and then you did cut field 1 delimiter, say that do the same delivered by the colon, that's going to get hello. And then if I did field 2, that's going to get there. And then I did field 3, that's going to get world. So, that's kind of how the cut thing works. Yeah. So, line numbers. So go back to the original grep statement. I did field 2, I actually want field 1 because I want the line numbers. So this is the field 1, this is the field 2, everything after that colon. So now I'm just getting the line numbers, right? Sweet. So, and then I take, what I do now is, this is anything in bash. If I go like a equals, and I do a $sign like this is a subshell. So I could do a command, this will take the output of this command and apply it to this variable. So I do echo hello, and I do echo star A, it'll say hello. But the thing is when you think about splitting, right? This is not going to handle splitting. So if I do echo hello there, I think the A will only be hello. No. I think that might be. Wait, I want to see echo star A. This is ZSH, so it starts with 1. That's interesting. It's taking it as a string. Okay. So let's do a different command here. That might be a better example. A equals this is, you don't normally put ls into a subshell. Yeah, so it got the whole output. Anyways, that's a subshell. But I want to see if that handles differently in bash. A equals ls. Hmm. Okay. Yeah. Anyways, I just wanted to test out, how uh, the splitting would happen with the strings, but I don't think this is a case where it's just storing everything into A, the whole output. Normally, what you'd want to do to prevent splitting is, surround this with quotes. But in this case, we want to take advantage of the splitting. And if I put this is here. Let me show you what an array is first. So A equals boom. That's saying you made a new array. If I want to add something to the array, I could do A plus equals hello. Add something else to the array. Goodbye. And then if I echo a first element in the array, get hello. If I echo the second element in the array, I get goodbye. So that's an array. But what I could do is take advantage of the splitting. And if I go like this and I surround this with those symbols, then I'm saying put the output of that subshell into an array. And I'm going to take advantage of the splitting. So if I do echo star A0, you get the first file. If I do echo -A1, I get the second file, right? That's because it's, when I do ls-l-1, right? It shows all the files on new lines. But if I did this, say it like A equals boom, and then I just did hello, then I did another new line, what is that? And then I ended it like that. See, all the new lines means that it's any space. It could be a new line or a space or a tab. I think a tab. Any space, anything of space indicates that, hey, there's going to be a new element. The elements are delimited by spaces. So now if I do echo star A0, whoops, whatever. I get hello, and then the next element would be what is, that. So that's, what's going on there. And then if I do -1, I get the last element in the array. So go back to that, A equals, you could just do this again. No, let's just do, what is that? Boom. If I want to get, the last element, that, I do A -1. And this is technically ZSH, but this should be the same. This should also apply in Bash, I think. No, it will apply in Bash, but I think this will work in ZSH is what I'm saying. Yeah, so that's the last element. So I'm getting the last element. So in this case, in this graph, boom, we only want the last element, so that's why we do that. Because we want to find the last case, the last init function call. So we're finding this line, 61. And you can see that the last line right here is 61. Yep. And then boom. I'm doing this. I'm saying if the sprite sheets variable, which we set up here, is there, then we're gonna do one thing, and if it's not, we're gonna do something else. Then with this said, the I means you're gonna write to the file. Then last match is the line number. Then A / means we're gonna append something after that line. And what we're going to append is this, right? So that's when we're adding the new init function. We're going to add it to init.lua. Oh, whoops. Somehow I made... There we go. And this is doing the same thing, but it's writing something else. It's appending something else. It's appending the same line, but appending something else after that line. Yeah, so that's that function. The new state function pretty much does, something pretty similar. And I forgot to show you that this, I think I told you this regular expressions matches. Yeah. So yeah, this does pretty much something pretty similar to that. This set is a little different. We're applying this to the file with the -a. So we're saying anything that matches this regular expression is aligned with this regular expression. We're going to delete any line that matches that regular expression. I know it's saying double quotes to prevent word splitting, but I mean, normally there's not. It's against like Unix to add spaces to files like you can, but like it's like that's a terrible thing to do. Why would you do that? So I don't know. So whatever. So I'm removing some files. Here I'm doing the same, type of approach as before. Add more boilerplate. Yep. And find something. RF means recursive. F means force. This I'm doing the same thing as before as I did in the function, to get the arguments. But this case I'm getting the arguments for the script and not the function. And so if I call, say this is me calling the function, I go helper in the terminal like that. But then if I did new UI after helper, I'm just going to find the new UI argument. This should be arg, not args. Plural thing is messing me up. And then I'm going to shift back one. So whatever is the second element will be the first, the third will be the second, the fourth will be the third, so on. And I'm taking all of the arguments and applying them to this function. And it says double quoting to avoid word splitting, but I'm taking advantage of word splitting for this because now, so that's why I'm doing the shift beforehand. And I believe that is everything. Hopefully this will help you write less boilerplate and automate you writing boilerplate.